Welcome to the lesson Mechanical Design Part 2, Gears. A gear or cogwheel is a rotating machine part having cog teeth or cogs which mesh with another tooth part to transmit torque. Gear devices can change the speed, torque, and direction of a power source. Gears almost always produce a change in torque, creating a mechanical advantage through their gear ratio, and thus may be considered a simple machine. The teeth on the two meshing gears all have the same shape. Two or more meshing gears working in a sequence are called a gear train or a transmission. A gear can mesh with a linear tooth part called rack, thereby producing translation instead of rotation. Applications of gears include toys and small mechanisms, appliance gears, power transmission, space gears, and control gears. Due to plastic gears' relatively recent coming of age, many products in the marketplace still use steel gears. In fact, plastic gears have always had a hard time shedding a negative stigma and concern with their use, dating back to when the only applications for plastic gears were found in toys and other non-critical applications. Through advancements in plastic resin and the manufacturing technique, however, plastic gears today can be utilized in a multitude of crucial applications, from transmitting amounts of torques to accurate positioning of critical components in medical devices. Plastic offers many benefits, including design flexibility and significant cost savings. Plastic gears possess many advantages over those made of metal. Plastic gears are lighter, quiet, retain an inherent lubricity, and are corrosion resistant. They can be produced in a variety of types, including beaver gears, offset beaver gears, spiral beaver gears, helical gears, metric gears, metric spur gears, plastic worm gears, and more. Cams, locks, ribs, webs, shafts, and holes can be molded into plastic gears in one integral design, in a single operation, opening the door to significant lower production cost. This versatility have paved the way to a nearly endless list of applications. The primitive gears are made of wood. This machinery made of wood, except for some iron fittings, is typical of milled work from Roman times. None of it would have seemed novel to Vitruvius, because the wooden construction leaves few traces in the course of centuries, and it is industrial, not mentioned in literal works. Very little is known of classical machinery, but the few archaeological discoveries that have been made show surprising ingenuity and skill. Types of skill gears are classified in spur gears, helical gears, beaver gears, worm set gears, and rack, and the pinion set. Spur gears. The tool's profile is parallel to the axis of rotation, transmits motion between parallel shafts. The helical gears are the teeth inclined to the axis of rotation. The angle provides more gradual engagement of the teeth during mashing, transmits motion between parallel shafts. Beaver gears are the teeth formed on a conical surface, used to transfer motion between non-parallel and intersecting shafts. Beaver gears are useful when the direction of a shaft's rotation needs to be changed. They are usually mounted on shafts that are 90 degrees apart, but can be designed to work at other angles as well. The teeth on beaver gears can be straight, spiral, or hybrid. Straight beaver gear teeth actually have the same problem as straight spur gear teeth. As each tooth engaged, it impacts the corresponding tooth all at once. Worm gear sets consist of a helical gear and a power screw, used to transfer motion between non-parallel and non-intersecting shafts. A worm drive is a cylindrical gear with a shallow spiral thread that engages the worm gear in a non-intersecting perpendicular axis configuration. Efficiency of a worm drive is determined by the lead angle and the number of threads in contact with the worm gear. A high lead angle on the drive reduces friction losses and heat. A low lead angle reduces gear speed while proportionally increased torque. Friction is an issue with all worm sets. The worm gear cannot transfer motion back to the worm drive in most instances. Lubrication and the ground teeth both contribute to the set's overall silence while minimizing friction. Worm gear sets are usually produced in pairs due to their precision. Rack and pinion set. A special case of spur gears with the gear having an infinitely large diameter. The teeth are laid flat. The types of gears are summarized. The nomenclature of spur gear teeth is illustrated in this figure. Backlash is equal to tooth spacing of the driven gears minus the tooth thickness of the driver, which is measured on the pitch circle. There are some useful relations of gears for transmission. Capital P equals to N over D. P is the diametric pitch, teeth per inch. N equals to number of teeth. D equals to pitch diameter. Lowercase p, meaning circular pitch, equals to pi d over n. Capital P times lowercase p equals to pi. The speed ratio of the conventional gear train, NV, equals to minus N2 over N3 times minus N4 over N5 equals to omega 5 divided by omega 2. Therefore, the speed ratio is equal to output over input. Also, the speed ratio can be expressed as plus minus product of number of teeth on driver gears over product of number of teeth on driven gears. Planetary gears, also referred as epicyclic gearing, consisting 3 elements: sum gear, planar gear, and ring gear. Sum gear is located at the center of transmission torque to planar gears, orbiting around the sum gear. Both systems are located inside the ring gear. In the tooth formation, sum and the planar gears are externally meshed and the ring gear internally meshes. Planetary gear is found in many variations and arrangements to meet a broad range of speed ratio in the design requirements. Planetary gear system is used in various applications, such as clocks, lunar calendar, card mirror, toys, gear head motor, turbine engine, and many more. Planetary gear center can move. Planetary gears are used to achieve large speed reduction in compact space. Planetary gears can achieve different reduction ratios by holding different combinations of gears fixed. Planetary gears are used in automation transmissions of cars. The reduction gear connects the main engine to the propeller. The propeller operates at 100 RPM. The engine operates at about 400 RPM. Thank you for your learning and listening.